Hello everybody, this is the last one for this homework section. This particular problem, I think this is the third time we've actually done this. Hopefully you're not tired of it, but it's good practicing the same thing over and over, making sure you understand the concepts. So let's just do this. So we have a rate, units, tons per hour, and we have unprocessed gravel arriving. And so we're going to draw a picture of what's happening, just so you understand. So you have gravel arriving at a plant. So I'm going to draw a beautiful truck. And it's bringing gravel, piles of gravel to this plant. So you have this mountain of gravel. And they tell you the rate at which it arrives is G of T. So I'm going to write that statement. G of T is the rate of arrival. It's tons per hour. And then, I'm going to do y1, let y1 equal that. And you should put that into your calculator. I should have done this before I started the problem to save us some time, but I did not. It's not too bad, I can get it in pretty quickly. Done. So put that as y1 in your calculator. Then let's keep reading what's happening. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. So when T is 0, now we don't have a variable for the amount of gravel. So I'm going to do this. A equals 500 tons. And I'm going to let A equal the amount of unprocessed gravel. I have an extra C there, but I can get rid of it. There we go. So now we have a new function. We defined A as the amount of unprocessed gravel. We could do A of T also, but I think that's fine. Let's keep going. During the hours of operation, the plant processes gravel at a constant rate of 100 tons per hour. So we have a new function. Now, you don't have to do what I'm about to do, but I'm going to just do this. Y of 2 equals 100. But what is that? That's the rate of removal. So what's happening as the truck brings in the gravel, the pile gets bigger, but then I'll make a conveyor belt here. Then they put rocks on this conveyor belt, take it away to a building that processes the gravel. So we're looking at the hill of gravel. That's the unprocessed gravel at the plant. So part A says, find G prime of 5. That's pretty easy. In our calculator, we just plug that in, which in your calculator would just be y1 of 5. And you can literally just put that on your screen, which I'm going to do now. Make sure your mode is in Radian mode. And I'm going to use alpha trace, parenthesis 5, end parenthesis, and I get 98.14, which is not correct. So let me make sure I put my function in correctly. 90 plus 45 cosine x squared over 18. Oh, I'm a liar, pants on fire. Let's back up a little bit. What I put there would only find for you okay, let's start all over. So they want G prime at 5. What I found for you is just G of 5. I want G prime. So I need to, in my calculator, do the derivative of y1 at 5. So I'll tell you the steps. It's going to be math 8. You put in x, your function, you put in y1, and then 5. And we get negative 24.588, or 587, whichever you prefer. I'm going to put a squiggly equals because it's an approximate. And that's part A. But we're not done. Remember, go back, read the question. We found G prime at 5, but it says using correct units, interpret your answer in the context of this problem. So G prime of 5 is the derivative of G, and it comes out negative. It's important you see it's negative. And you guys should know if a derivative is negative, then the function, original function, is decreasing. So now we know G is decreasing. So what is G? Well, I'm going to highlight here what G is. G is the rate at which unprocessed gravel arrives. That's G. So that's what's decreasing. So how are we going to write this out? So the rate at which unprocessed gravel arrives is decreasing. So I'll write that. The rate at which unprocessed gravel arrives, that's just G. And since G prime is negative, I say is decreasing at the rate of negative 25.588. And I need units. So let's look at what's going on with units. Actually, does it say units? Yes, using correct units. So here's some side work. G prime of 5 is dg dt at t equal 5. Well, it's just the change in G over change in T. What are the units of G? That's going to be tons per hour. What are the units of T? That's hours. So you have tons per hour per hour. So you can write it just like that if you wish. Tons per hour over an hour. Or you can rewrite it as tons per hour squared. Just multiply by the reciprocal of hour and you get that. So that is part A. Let's jump down to part B. Find the total amount of unprocessed gravel that arrives. So they're not asking for how big the pile is. They just want to know how much has arrived from 0 to 8 hours. So this is a pretty straightforward problem here. So we have the rate of arrival. So if we integrate the rate of arrival, sorry about my screen, I don't know why it's freaking out like that. If we integrate the rate, actually G is already a rate. That gives us how much gravel has arrived. So simply put that in your calculator. You're going to do math 9. You're going to integrate from 0 to 8. Your function will be y1. We've already put that in our calculator. And so I get an answer of 825.551. And we're done. That's part B. Part C is the amount of unprocessed gravel at the plant increasing or decreasing. So the key word here is increasing, decreasing. And when you hear that, you should think derivative positive or the derivative negative. So we need to find out the derivative at that time. So part A, that was only the rate of arrival. That's completely different, actually. Sorry about that. Part C. So we need to know if the derivative is positive or negative. The derivative of what? The derivative of the amount of unprocessed gravel at the plant. Well, earlier, we defined A as the amount of unprocessed gravel at the plant. So what is A going to be? I'm going to write this down. A of T is the starting amount of gravel that you have at the plant plus the amount of gravel that arrives at the plant. You subtract the amount of gravel that was taken away to be processed. And so the starting amount we found earlier, we listed it here as 500 tons, so it's going to be 500. The amount that arrives, you integrate the rate of arrival to give you the amount. So we integrate from 0 to t. We had to change our variable in our function because t is used in our integrand. And then you subtract the amount taken away, but the amount taken away, you integrate the rate at which is taken away. Now we already told the rate at which is taken away is 100. Now I know some of you are bothered, there's no variables in there. You're used to variables or functions. 100 is a function, it's just constant. So don't let it bother you that it's just 100. So to find out if increasing and decreasing, we already said we need the derivative, so we're going to find the derivative of this. The derivative of 500 is 0. Now here, we're taking the derivative of an integral from a constant to our variable t. We learned all you do is plug that in. Similarly here, you plug it in for x, and we'll talk about that. So this will be g of t minus, if I plug in t for x in the last part, there is no x. So when I plug it in, the t doesn't go anywhere, so I just end up with 100. So I need to know if this is positive or negative at 5. So now, that's going to be g of 5 minus 100. I'll do that in my calculator. So on my calculator, I would just, on my home screen, bring up y1, parenthesis 5, and parenthesis, minus 100. I get a negative. I'll write that down, negative 1.859. Since the derivative is negative, what do we know? Therefore, we know that the amount of gravel is decreasing. So our final statement, the amount of unprocessed, this is letter writing, gravel at the plant is decreasing. Again, we know that because A prime of 5 is negative. That's part C, on to part D. All right, we're almost done. Hang in there. It's the last problem. Maximum. There's your keyword for D. Always looking for keywords. Where do maximum and minimums occur? You should know at critical points and endpoints. We know the endpoints are 0 and 8. That was given. So now we have to find the critical points. What is a critical point? A critical point is where the derivative is 0 or undefined. So we found the derivative previously. So we're going to take the derivative, which is gt minus 100, set that equal to 0. Well, how do you find that? You need that in your calculator. I'm going to add 100 to both sides. You want to find when g of t equals 100. How do you do that? Well, you graph both those functions on your calculator, g of t and 100, and you find where they intersect. So you need to set up your windows. So hit your window button, and your x min is 0 because it starts at 0, the time, and your x max is 8 because it ends at 8 hours. The amount of gravel, we want to know when they equal 100, when g of t equals 100. So my minimum, I can start at 0. My max is any number over 100. I'll just pick 200 to put 100 in the middle. I graph both of those. You should see the graph of the rate, and then the graph of, the graph of the rate in and the graph of the rate out, and they should intersect. And so you just find the intersection point. To find the intersection point, you hit second trace, which is calc. You want the intersection, you can just hit 5 or scroll down to 5 and enter. It asks you for the first curve, and they ask you in top left, is the first curve y1? It is, so I enter. Is the second curve y2, which it is for me, and hit enter. You put your blinky bob anywhere near the intersection and hit enter again. Make sure you hit enter again or you won't get this correct answer. So it comes out to be, I'll call it at A equals 4.923. I'm going to store that number because I need to use that in a second. So I go to home screen, second quit, and I hit X, the store button, alpha A. Now that number is stored for me in A. So now I have the critical point. So the maximum can only occur at 0, or the critical point we just found, or 8. How do we know which one's the biggest? Well, the most obvious way is to find the amount of gravel at all 3 of those times. So we're going to do that next. Well, A of 0 is easy. They told us the starting amount is 500. Done. Now, to find the amount at A, I use the formula that we found earlier in part C. My mouse just died again, so I'll highlight it for you here. So you take that formula, the amount of gravel at any time is given by that. So it's 500 plus the integral from 0 to A of g of x. And that could be y1 also because we defined that as y1. Minus the integral from 0 to a of 100 dx. Now just put that in your calculator. I'll do that real quickly. Actually, through the magic of having the answers in front of me, I'm just going to give you the answer to save us time. That comes out to be about a 635.376. Now, to find the amount at 8, you don't have to retype that whole equation out. Just use your up arrow, go back to your previous equation that we just did with A, hit enter. Now use your left arrow and change the A's to 8s. If you do that on your calculator, it'll save you a lot of time. If you work this out on your calculator, you get 525.551. Now, clearly the maximum is 635.376. So let's read the question. Is it asking for a time or is it asking for the amount? What is the maximum amount? So we need to answer that question. So we're going to say the maximum amount of unprocessed gravel is 635.376 tons. Done. That's it. That was a long problem. Hopefully you understood that and you're able to follow. If you have any questions, make sure you just let me know. All right, have a great day.